Hi, my name is Anindya Afina Carmelya, and as advised from Editor-in-Chief at Indonesian Journal of Electrical Engineering and Computer Science, here I will present you my paper in the next 15 minutes. So, the title of our research is SRCNN-Based Image Transmission for Autonomous Vehicles in Limited Network Areas, with my paper ID number is 39333. So the background of our research is we know that high quality images are crucial for autonomous vehicle functions such as for navigation, obstacle detection, and environmental understanding. Transmitting high resolution images over constrained networks present significant challenges due to bandwidth limitation. And the objective of this research is to develop an image transmission system using super resolution convolutional neural networks, or SRCNN, to enhance image quality without increasing bandwidth requirement. Our research motivation is enhance image quality received by autonomous vehicles without increasing bandwidth requirement, to ensure critical visual information is preserved while minimizing data transmission loss, especially in scenarios with limited or unstable network bandwidth. So our approach in this research is use SRCNN to upscale low-resolution images transmit over constrained network to high-resolution images. Three SRCNN model configurations, such as 915, 935, and 955, were tailored to the specific needs of autonomous electric vehicles operating in limited areas. In this figure, we can see that the low-resolution image is transmitted via transmitter, such as a LoRa, and received by the receiver. And then the SRCNN process began. So the low resolution image that has been received by the receiver is upsampling using the bicubic interpolation. Then the upsampled version of that low resolution image undergoes to the three convolutional layer of SRCNN, such as patch extraction and representation, nonlinear mapping, and reconstruction. As the result, we can obtain the high-resolution images significantly enhanced from the original low-resolution image input. Here, the phase one of our research, data acquisition. So location where objects capture is at Science and Technology areas, Samaun Samadikun Brain, Bandung in Indonesia. To capture those objects, we use 4K boost lens camera. There are 15 videos obtained and they are converted to frames, resulting in a substantial number of frames divided into training sets, which has 348 images, validation sets with 157 images, and last but not least, testing sets with 55 images. Here's the phase two of this research, model preparation and training. So the training steps used in this research are 200,000 steps with Adam Optimizer. Training metrics that we use in this research are training loss, validation loss, and training PSNR, also validation PSNR. Filter sizes we use for 915 model configuration are 9 by 9, 1 by 1, and 5 by 5. For 935 model configuration are 9 by 9, 3 by 3, and 5 by 5. And last but not least, 955 model configuration are 9 by 9, 5 by 5, and 5 by 5 across all the three convolutional layer of SRCNN. Cool. So here's the phase three of the research, model testing. Evaluation testing using testing datasets. As we know, that testing dataset has 55 images. Metric that we use to measure the model performance is mean PSNR of all the 55 images from the testing datasets. Moreover, images scaled in three different scales, such as 2 times, 3 times, and 4 times. We can see here there's a table 1, table 2, and table 3. We can see that the best average value is from the 2 times scale across all the three models. And it reached around 33 decibel of PSNR value. And the best performance of architecture models is from the 955 models that reach 33.655 decibel. This is the result and discussion. So model 915 present quick learning, also stable performance with high initial loss. We can see here in the figure that training loss and validation loss drop before the 50,000 steps, same as the training PSNR and validation PSNR that increasing before the 50,000 steps. Here's the model 935. The model 935 is tend to rapid convergence but kind of potential overfitting. So we can see here that the training loss and validation loss is dropped near the 50,000 steps, followed by the training PSNR and validation PSNR that also increasing near the 50,000 steps. This is the model 955. The model provides the most reliable and effective configuration with high initial performance. We can see here that train loss and validation loss is dropped far before the 50,000 steps, followed by the train PSNR and validation PSNR that also increasing far before the 50,000 steps. Here is the comparative analysis from the result and discussion. We can see that model 955 is the best and most consistent performance across all scales, followed by the 915 models that has a strong performance with some variability. And last is the model 935 has consistent mean values, but also lowest minimum value. Here's the simple input and output. We can see that in the left side, there's a sample of input image. And in the right side is an image output given by a super resolution architecture model that 955 model of super resolution model architecture. So this is the conclusion of our research that SRCNN effectively enhance image quality for autonomous vehicles operating in constrained network areas. Model 955 emerged as the most reliable and effective, showing superior performance and consistency. With the input image resolution is 170 times 170 pixels, the same model could upscale the image up to 510 times 510 pixels with a PSNR of 30.926. The resulting images are pretty good. Transmitting these images over IEEE 802.11ac Wi-Fi network will prove efficient, but using LoRa network will introduce significant delays with 128 times 128 pixels image will taking 5.6 seconds. So I will say thank you for Indonesia Endowment Fund for Education, or Lembaga Pengelolaan Dana Pendidikan through the Riset dan Inovasi untuk Indonesia Maju, program organized by the National Research and Innovation Agency, or BRIN Indonesia. So that's my presentation of this paper. I hope this insight will provide you a better understanding of this topic. Thank you for all your attention and participation. See you in the next another time. Bye.